welcome to DG Blaster Works. My name is Dallas, and today we're going to do a mod guide for the Nerf Infinus. This one I got at my local Goodwill for $9, which when you consider what these things cost brand new is a heck of a deal. So what I've done is the motors for the flywheels are run off of a 3S LiPo, but they are controlled by a 2S LiPo, which powers the main board, the dart loading mechanism. It also powers the pusher motor. So I've got 3S Krakens and Daybreak flywheels in a 40.5 millimeter cage. And as you can see, the dart loading functionality works just fine, which is what makes the Infinus so intriguing. So there's actually two LiPos in here. If I want to swap out the flywheel cage for something that runs on 2S motors, I can do that and still keep the rest of the system also on 2S. So without further ado, let's get into that mod guide. Alright, so I've got my Infinus open. So I'm going to power the main board off of this buck converter. The first thing I've done is I've removed the stock cage and motors. And that had 3 wires, 1 positive and 2 negative. I'm assuming the second negative is for motor braking. But I stripped the positive and the first negative in this combined wire set, and I hooked them up to a Honey Badger motor. Right now it's just running off of the stock D batteries. I satisfied all the locks and pulled the rev trigger, and the Honey Badger motor fired up. So those are the two I'm going to use. Those are going to connect to the signal pins on this relay, there and there. And then those are going to control the power to the flywheels direct from a LiPo. Back here, I'm going to try and get to the pusher motor and do the same thing. Take the leads that would go to the pusher motor stock and use those to control another relay so I can run the pusher motor off of a LiPo. Alright, so I've pulled out the screw there and there. And that allows me to move that out of the way. And this part of the dart loading mechanism just lifts out. And then the pusher assembly lifts out. So now I can work on rewiring that motor. Alright, so while I had the pusher and part of the loading mechanism out of the way, I went ahead, I loosened those 2 screws and took a screw out of there just so I could lift all of this up enough to fish my positive and negative wires coming from the LiPo to the motors. So I'll have those in place already when I go ahead and put the pusher motor back in, and then hopefully it won't be too hard from there. Alright, so the cage and loading mechanism is back in place. So what I've done here is I've got the 2 leads that would normally go to the stock pusher motor going to my signal inputs on the relay, and then I've got the negative for the pusher motor coming from the LiPo going to the common and the normally open. And then I just gooped the whole thing up with liquid electrical tape to prevent any shorts, because that's going to live down in here right next to the main board, so I don't want anything shorting out. Alright, I wish I had done this to begin with, but I tested the previous relay setup for the pusher and I got runaway. So I've rewired the so negative comes in to the normally closed, and then I've got positive on the common and the normally open. So when the relay closes, you have positive connected going to the motor, and when the relay is open, you've got both the positive and the negative of the motor connected to the negative of the battery to provide motor braking for the pusher to prevent that runaway. Alright, so before I get the voltage buck wired into the main board, I decided to go ahead and hook it up to a LiPo battery and set the output. Not being a one to trust displays that come on equipment, I did use my multimeter to verify that I'm getting 5.97 volts on the outlet. Okay, so it might be a little hard to see what's going on here, but I've got the positive and negative coming from the battery. The negative is going through a fuse and then connects to the negative for the pusher motor and the negative in on the voltage buck. The positive from the battery is connected to the positive for the pusher motor, and that is going straight into the positive in on the board. Okay, so here I've got a bank of three 10,000 farad capacitors, all wired in parallel. I've got the negative coming into my negative motor lead, going into my relay here to the common, and then I'm going to have negative going out to the motor here on the normally open. These are the wires that were powering the stock motors. They're going to act as my signal wires for this relay. The positive wire coming off of my capacitor bank is going to get tied in with the positive going to the motor. So in this case, the positive and the negative going to the motor are going to get wired to an XT60 connector so that I can easily change out motor and cage combinations just with that plug and not have to rewire everything. Alright, I've got my daybreak cage wired up and installed. I got the relay and the capacitor bank glued down. I tested the flywheel system and this thing rips darts. So now it's time to button it up and see how it performs. So here is a wiring diagram of what I've done. So starting from the 2S LiPo, we have one positive coming down going into the voltage buck. We also have the negative coming to the voltage buck. Off of the negative, we have one lead going to the negative of the pusher motor. And then coming off of the positive of the pusher motor, we've connected that to the common of one of these little relays. The normally closed is connected to the negative of the 2S LiPo to provide motor braking when we let off the fire trigger. The normally open goes back to the positive. This relay gets its signal from the wires that were originally connected to the pusher motor, and they get their power from the stock Infinus board, which is now being powered by our voltage buck, which is reducing from LiPo down to 6 volt. The stock board is still connected to the stock rev switch, the stock fire switch, and the loading mechanism. The stock wires that would normally provide power to the flywheels have now become our signal wires to another relay. I've split the power system because for this particular build, I wanted to use Krakens on 3S, but I also wanted to be able to swap out the cage and flywheels and motors for a lower power 2S setting for HVZ if I ever desired. So coming from the 3S LiPo, pretty standard, we're going into the common of the relay. And from the normally open, we're going into the negative of the motors. And then from the positive motors, we're going back to the positive of the LiPo. In parallel, I also have 3 of these 10,000 microfarad capacitors. And what those are going to do is, As soon as this relay closes, those capacitors are capable of instantly dumping whatever charge they have right into these motors and giving them a really fast spin up. They will also help provide supplemental current in between shots to improve the recovery time of these motors when you're firing at full auto. So that is the wiring diagram of my Infinus mod. Alright, let's see what kind of chronograph readings we get. This is daybreaks in a 40.5 millimeter cage, 3S Kraken motors. So we got an average of 144, fire rate of 5.2 darts per second. Alright, modified Infinus, mixed magazine of darts. The motor for the pusher, the motor for the flywheels. Hi, kitty. Hi. Hi.